Here's one problem. xy plus x bar y z bar plus yz. It says simplify that. I know I can simplify the bottom half. I mean the last two. If I factor a y out, what's left? Z plus z bar x bar. Where's my list of rules? We have a rule here. Where was it? Which one number? I can write it for you there. It says a plus a bar b is equal to a plus b. Check your notes. You have that somewhere. I'm looking on this book to see if I can find it here. What is it? 10, number 10? Okay. So if I use that here, this should simplify to what? Z plus x bar times the y now if you distribute that again, now look at these two. What can you factor out? A y. If you take a y, what's left? X plus x bar. We have a rule that says a plus a bar is always equal to what? 1. If I use that rule here, what's x plus x bar? 1. Y plus yz. Notice what they have in common. Y, 1 plus z. What's 1 plus z? We have another rule that says 1 plus a is always what? 1. That's a 1. So your answer is y.
Gee, what does that top one say? The a plus a bar?
A plus a bar b is equal to a plus b. So when I take a problem that says simplify, we can simplify it. If I just pull something, just look at, oh, let's do this one. I don't know if that problem is completely simplified already or not. This is not the best way to simplify, as I said before. You will see soon, but we gotta make you pay the price for a while before we get to the other ones. Let's try another one. Simplify. We have x, y bar plus z times x plus y bar times z. Just like in math, it really doesn't matter which one you do first. You can, but you want to multiply by z later, or you want to do it first? It's up to you. You want to do it first? So multiply these two by z. Bring that z in. That becomes what? xz plus y bar z. xy bar plus z. Now we're going to use the FOIL method. The FOIL said what? You can multiply this times this times that, this times this, and this times that. X, y bar, xz. Plus x, y bar, z. Z, x, z. z, y bar, z. We have a rule that says if you have a times a, if they're the same thing, what's the answer? A. So when you see x's twice, you don't have to write it twice. I see the y bar twice, I'm not going to write it twice. Oh, what do you know? Look at these two. Are they the same thing? This is what? Zx, and this is what? Zy bar, yep. We also have another rule that says if you're adding two of the same thing, the result is A. That means I don't need both of these. I can drop one of them out.
Can you drop a y bar?
Well, let's look at y bar z, which is these two, right? So if I take these two, I can take y bar z out. We have what? X plus 1. And a plus 1 is always what? 1. That's a 1. Again, you could factor a z out here, and you end up with what? X plus y bar if you want to, but either one is good. If they ask you to give the answer as sum of product, there's your sum of product. If they ask you to write your answer as product of sum, this is product of sums. I mean, it's not a bad algebra to do there. It's not like, oh, it can't be done. If I pick the right problems, let me try another one. This one says reduce or simplify. I have A bar, C bar, D bar, plus A, C bar, plus B, C, D, plus A bar, C, D bar, plus A bar, B, C, plus A, B bar, C bar. I'm looking at the first two right here. I can factor what? C bar out. What do we have? A plus A bar what? D bar. Again, we have a rule. Since I'm using A and B, I'll use X and Y. It says X plus X bar Y can be written as X plus Y. I just used that one in the previous example. I just used A and B instead of that. So this one I should be able to simplify it to what? A plus D bar. And if you distribute that, that's C bar A plus C bar D bar.
Is it the same thing as A bar plus AD?
A bar plus, what is it?
AD?
No.
It's not
Oh,
the
yes.
same?
I mean, doing if you have something like this, if you have A bar, X bar plus X, Y, that can be simplified to X bar plus Y. Yes. I thought you meant this one. We're looking at this one. So let me write the rest of the problem so I don't have to keep looking back and forth. And I noticed something a few minutes ago. I looked at it, and that's this one and this one. So if you factor C bar A out, what's left? 1 plus what? B bar, which is a 1, so you end up with what? C bar A. So this is gone. That's useless. Let me rewrite the problem again. I don't mind writing it again. Now let's look at these two. I think that's the question you just asked me about it.
What happened to the A, B bar, C bar?
That's gone. These two simplify to C bar A. Remember these two?
Oh yeah, there's those two.
So the equivalent of those two is this one. So that's the rest of them. Now let's look at these two. Let's find out the equivalent of these two. These two actually, you can see what? D bar in them. What's left? C bar plus CA bar. So that you should be able to write that using that rule here. Doesn't matter if it's A bar or not. Y could be anything. So this is what? D bar, C bar, plus A bar, D bar. So here's the first one, C bar A, or AC bar. I like them to put them in order there. These two purple one, I'm going to change them to what? C bar, D bar, that's a C bar, plus A bar, B bar, plus B, C, D, plus A bar, B, and C.
AB or AD bar?
Which one?
You have A bar, D bar?
A bar, D bar, yeah, here instead of B bar. Thank you.
Could you do the first and last?
First and last, nothing common.
Oh yeah, A. I didn't do this.
Yep. What else? BC here. You end up with D and A, B bar. Doesn't help me. In terms of simplifying, it looks like that's as far as we can go with it. It went from 6 3-input OR gates to 5 of them, and 3 of them are 2 inputs. Maybe I can sneak in one more, I don't know. Oh, that does not look pretty. Here's what I see here. A bar plus D bar plus B bar C multiplied by B plus D plus AC bar. Add to it B bar, C bar, D bar. Add to it A bar, C bar, D. Again, you're going to be adding these terms, so it might be useful to go ahead and distribute that. This, which will give me what? A bar B. That's what? A bar D. And this one is what? That's a 0. Why? AND gate with A bar and A in it. Gone. Now let's take the D. Multiply, that's B D bar. D bar and D. 0. That's A, C bar, D bar. Now the last one, B bar C times B, that's what? 0. B bar C D. And what's the last one? That's a 0. Why? You get C and C bar in it. That's an OR gate with C and C bar. That's a 0. Here's the rest of the problem. Now we're going to look and see if we can simplify that. Bless you. Look at these two. Oh no. Nope, my mistake. This does not have a bar on it. I thought it does. The eyes start to go now.
A bar, D bar, second and last.
Second and last. Good. If I factor A bar and D, what's left? 1 plus C bar. What's 1 plus C bar? 1. So that'll combine to A bar D. So let me write the rest of the problem. So that term is gone. I'm looking for B and D. I see D bar, I see D. Oh, I just noticed that. See these two? If you factor a D bar out, what do you have left? B plus B bar C, which simplifies to D bar times B plus C, and you can write that D bar B plus D bar C. So let's write the rest of it now. Let's rewrite that. I start to dislike these problems. This method gives me a headache.
How does B plus B bar C equal B plus C?
A plus A bar B
Oh, right.
equals A plus B. So I use that one. Now, I forgot what I was. Let's see. That's here. So I got to add this one. I see D bar, don't work out. I see a D, don't work out here. I see a B, where's a B? Oh, right here. See these two? I can take out what?
D bar.
D bar out. C plus C bar A, using that equation. A D bar plus C D bar. So here we go. A B, or A bar B, A bar D, B D bar. Now these two here, I'm going to replace them with what? A D bar plus C D bar. And I have another one, which is what? C B bar D. I can take these two and simplify them. Same rule. If you factor a C out, what's left there? D bar plus DB bar, right? Which simplifies to C times D bar plus B bar, and I can multiply it out. So here we go. A bar B plus A bar D plus BD bar plus AD bar, and the last two can simplify to CD bar plus B bar C. These two don't work out. You can't simplify these two.
B D bar and CD bar.
CD bar is gone. Which one? So each one has two now. See, this one, they can't. You can factor a D bar, but you have B plus C.
If you add back in like the C, B bar, D,
The question, if you add in the C, one of those terms up there on the top, C, what was it?
B bar, D,
D bar D?
B bar, D.
B bar D.
And that would go with the very last one, wouldn't it?
Yeah, but we'll make it what? C B bar. Right?
Yeah.
So
CD that you can cancel CD bar.
So nothing. The way it does, it just eliminates that one. The question, if I add this, I can simplify it with this. No, because you can factor out C, B bar, and what's left? 1 plus D, which is a 1. So you still have that, and this just went away. So when you're at this point, if you're adding anything, it's really not going to help you simplify, unless there was something up there that you missed. I hate those. The only thing I can do at this point is start to factor something, see if I can share gates. Like if I take a D bar out, I have A plus C. Can I get A plus C somewhere, from somewhere else? Where I can use the same gate for two things if I was building them. But it doesn't look like I can simplify that anymore. I mean, we spend a lot of work on this. It looks like that's it. So I gotta look for shared gates. If I factor A bar out of this, I have B plus D. Do I have B plus D somewhere else? And I don't see it, B plus D. Nope. So that's what we start looking for. If I take a D bar, I have A plus B. If I take a d bar, I have a plus c. If I take a d bar, it's c plus b. If I take a c out of them, b bar and d bar, I don't see a shared gate. So I gotta just build that design. Use AND gate, AND gate, AND gate, AND gate, AND gate, AND gate, and order them together. 1, 2, 3, 4, 5, 6. 6 AND gates and 6 input OR gates. If you don't have 6 input OR gates, you take 2, feed them together, take the result, feed them, take the result, feed them, and keep adding them. And then doesn't look like I can simplify that. So that's as far as I can get with it. As I said, do we have a method that will make all this math useless? Yes. Not today. Tuesday. I can do these problems and guarantee you get the simplest form possible in maybe less than, maybe a minute. Top. That's it. 1 minute.
As long as they're like 3 or.
Yep.